Hello, everybody, and welcome to the first demo for our Cloud Field Day 15 presentation. We are from RackN, and we're going to be showing you how we're scaling infrastructure as code across sites and teams. And that's going to include, for this first demo, how we scale Terraform. We're going to be doing this by play acting for a fictional bank that we've created called RackN. I'm going to be the platform engineering chief, who's been doing this work for a long time. And
I'm Shane Gibson. I'm the senior cloud architect here. I'm new at RackN. I'm really excited to get started, Rob.
Excellent, Shane. I'm excited to have you here. We just hired you from Bank of Cloud.
Oh, yeah.
Well, we'll help you get over the battle scars from that. So let's dive in. Shane, you asked me to come over to your desk so you could ask me some questions about Terraform, and I'm happy to show you how we do it.
Yeah, so I'm trying to run this Terraform. Let me get over to trying to run this Terraform plan. And I saw these really cool videos you guys are doing. And it seems like it's really easy. I started, and I know that I needed to create a cluster construct. So I created a cluster, and then I created a template with my Terraform plan in it. Templates. And I started with this thing.
Okay.
I got it to run, but I had
where did you get this Terraform template?
Well,
is this something you've been sort of bringing around?
Okay. From Bank of Cloud.
I see that. Okay. I'll keep it between us.
Okay.
All right. So it looks like you've got some things in here that are hard coded. Looks like you have some different teams that are working in this. Tell you what, instead of digging into this just yet, can we jump back to the clusters view and just build a cluster the way RackN would normally have us build a cluster?
With just the standard template.
Let's just do the standard template and see if I can explain sort of how the Terraform is being generated here, and then we'll figure out how to replicate the Terraform you want to upload.
Okay, so we have this Terraform cluster that I created, but we're going to create a new cluster here, right? So I'm going to add a new cluster, and I was going to call this CFD 15 and East.
Okay.
No, we were starting with East. Yes.
Let's use our Amazon East resource broker for this. That makes sense.
And then, so what did you want me to do with the configuration?
So in this case, most of the defaults are great. We can just use the base cluster pipeline. For this, yeah, go ahead. Let's go ahead and change to the East. We're doing East, so let's use the broker for East.
And we want to create this cluster with just 3 members in it.
We'll just do a 3-member cluster. That'll keep things simple.
Okay.
And then let's set the colors and icon just so we can find this cluster easily in the system.
Okay. Well, my wife's favorite color is purple, so
it's
my favorite color too now.
You are a smart spouse.
All right. So I created that cluster, and it's doing something.
Excellent. Yeah. If you look over on the top right, there's an activity tab. And we can actually watch this pipeline being built until we get to this cluster provision stage.
Great, but where's the Terraform plan?
So remember we picked that US East broker?
Yeah.
That East broker is actually running the Terraform on our behalf. So we made a call, what we call a blueprint here, a work order, from that pipeline to delegate that to the resource broker in the system.
So can we create more brokers that allow us to create clusters with different personalities or different regions or?
Exactly. Let me show you something on the whiteboard for a minute that might help sort of understand all these pieces and how they're fitting together. Okay. So for this, we've started with a cluster and we're building the cluster.
Yeah.
Okay. The cluster at the point where, and you said we wanted 3 machines, so it had that as an input. And it also said, we wanted the East broker. What happens is, in this cluster, it builds a cluster definition, the list of machines, and it sends it to the broker, our resource broker.
And then the broker does the work on our behalf based on its configuration.
Exactly. It has the logic to build a Terraform plan.
So that must be where the Terraform plans are being assembled, managed, and where we can see what's happening with them.
Exactly. So we're going to take the Terraform plan you built and show you how it's actually built in Digital Rebar out of different component pieces.
Okay.
And so when that Terraform plan runs, it does what we expect, and it goes to AWS, and it asks for machines. And those machines are going to come back and join into Digital Rebar because we've told them how to join. Now, this itself,
See, that's where one of the problems I had with my Terraform is I couldn't get the machines to correlate in DRP with the AWS names.
exactly. Yeah, I noticed that somebody had created a couple of Amazon-looking names that we didn't have any background reference on. And one of
me.
That was you. Okay, well, we'll clean those up in a little bit before they flag an audit and we get in trouble.
FNG.
So here's what happens is in the Terraform scripts, what the system automatically does is it injects a machine create. And so this machine actually exists before Amazon has instantiated it.
That's interesting because that means we should be able to pre-configure it with a pipeline destination or a declarative state where to drive it to.
That's exactly right. So the machine
cool.
can be pre-configured into what we want it to be even before it exists. And that means we can run a pipeline on the machines immediately when they're created. We don't have to build custom cloud inits or try and stuff scripts into our Terraform to figure out what things are going to do. It's all going to flow together. And then what happens with this, so this is happening in parallel with the ID number that Terraform knows about the system, and then Digital Rebar is able to match them. The other thing that happens is this cluster is actually sharing information between the machine and the cluster, and it's going to wait until all those machines reach a ready state, and then we could do additional work where the cluster was building an application, installing logic, coordinating activities between the systems. So
that gives us the higher order orchestration over these small point tools that only have specific use cases, and then we can chain those or pipeline those together and incorporate the next, whatever is the next greatest thing after Terraform.
Exactly right.
Very cool.
So let's go back to the system.
What's here?
It was me moving it.
I would go back to the system if I could. Remarkable is a new software to me. It's remarkable. There we go. I see what you did. Okay, so we have the CFD 15 East cluster here.
Excellent. And at the end of that cluster run, what you're seeing here looks blank because it automatically switched into run mode. So once the cluster is built into work order mode. And so what that means is now we can submit ad hoc jobs to it. We're going to be doing that in the second demo when we talk about our Ansible queries a bit. If you wanted, you could actually resize that cluster right now. Just going into the editor, if you were to say pick.
Well, first I want to see our machines. This is where we actually manage the individual machine instances. So these must be the ones that came in from the cluster with the East 012 from our cluster size. These IP ones are the old ones I created with my hard-coded template.
Yes, and let's make sure we run a Terraform destroy later on to make sure we clean up what those instances are. Yep.
So from here, we wanted to do a resize of the cluster. Make it 5 machines, and then I can't get to there, so we'll go.
Yeah, and then there's a simple just rerun the pipeline for that cluster in work order mode, and that'll actually resize the cluster and we'll be able to see what's happening. But this hasn't answered your question yet because you wanted to see the Terraform being run. I know you've had a lot of experience with Terraform and that feeling the Terraform plan would be helpful. So
you said that it was being run on the resource broker, so I assume we come over here to the resource broker to see that.
Let's create a whole new cluster and walk through that process one step at a time.
Okay.
This time let's use our West Coast, our US West broker.
And then you said use the West Coast broker, so we'll go use the US West one. We'll leave it with the default here, and we'll change it to a green. How about something fancy? Home.
Excellent.
Great.
All right, so now that it's starting, we're going to go through the same pipeline. We're going to hit that same resource cluster provision, but now let's jump over to the resource brokers.
Okay.
And watch what's happening over there. So
presumably on the US West, and we actually see on the screen here, we have these jobs work orders running on it.
Exactly. So if you jump over to the activity tab, Here, you'll see it doing the work, and you can see we've queued up this. So the broker is a shared resource, and now we're actually funneling our Terraform work into a place where we can observe what's happening. And look at that. Does that look familiar?
There's my
You feel
code.
better?
I feel so much better
Okay,
now. Thank you.
So there's a Terraform run.
Yeah.
That looks good. Can you scroll down to the end? At the end of it is where that magic happens with the machine creates.
There we go. Boop.
So we're getting live updates from this Terraform plan running as it's actually creating components. And there, it just created the machines. And you can see this. This is where it's actually pulling back the IDs and the IP addresses and the regions. If you go over to machines now, you'll actually see where they're created.
There they are. There's our West machines that are now under management.
Excellent. And you'll notice they aren't doing the ones we built earlier for the expansion. They're running through their pipeline. So the 3 and 4 ones are. And now we just have to wait for those West machines to get started.
So those East ones are still in the build process. And then we're waiting on these West ones to be finished.
So are you creating a Kubernetes cluster in these machines, or what sort of a cluster are you creating?
In this case, it is just an undifferentiated cluster of machines.
So 3 EC2 instances with storage, et cetera.
Exactly. And so we're able to, now we have clusters that then go and say, okay, I want to install Kubernetes on that, and they'll run additional pipelines. So let me explain how that would work, because there's 2 pieces to it. If I was creating a Kubernetes cluster, when I create the machines, I'm going to start a Kubernetes machine install pipeline on the machines. So those machines will come up, and then they'll run, install containerd, install kubelet, right, go through that process automatically for me. Now, it can be differentiated based on if they're a leader role or a worker role, but you can actually, so you can specify all that. But when it comes up, you're going to set those pipelines. I don't have to do any additional work. The cluster is going to wait until those machines are ready, and then it will then start doing the cluster control plane build and doing the additional work to bring those pieces up.
This works on Amazon, it's work on Azure and Google Cloud.
And bare metal in your own data center as well.
Italian Cloud, what's it called?
And is there documentation for creating your own, effectively, if you have your own cloud or a cloud that's not currently supported, is there documentation on how to build out for that as well?
There is. We actually have a process. We worked when I added Oracle. I captured that whole design process.
Right.
And now what you are doing is you're mapping. And we should, one of the things I think we should do is show you the Terraform that Shane brought into the demo, and then show you how we decompose it, because every cloud has different Terraform. Every cloud reports different data back out of Terraform, and we had to normalize that. So a big part of this decomposition is our ability to normalize each one of the clouds. But it's Terraform. Now, one of the things we're doing for EKS automation is there's a resource broker for the, I'm going to answer the question. There's a resource broker for things like the AWS CLI. And when you run that broker, it actually can make AWS CLI calls. So we can run spin up EKS doing Amazon EKS calls, or we can do a Amazon discovery where we're outside of Terraform and we're just calling show me all my machines. There's actually a simple blueprint for that.
Cool. A quick question about the integration. After the process is able to integrate with some piece of company enterprise, for example, CMDB or something like that.
Very good question. That's what a lot of our large enterprise customers, that's the first thing they'll jump to, is usually an asset management or configuration management service. The next thing they usually will jump to is things like secret stores, like vaults, be able to inject passwords securely. One of the things that's always a challenge with infrastructure as code, how do you deal with secrets, passwords, and things like that? Service keys, those things that might be exposed in the infrastructure as code in your Git stuff. And so those sort of integrations, there's a couple stories we have for that with secure params. We use what we call params, which are like variable bits of information. We automatically can encrypt those, but we also have a plugin that lets you use external vault services to inject those secrets securely.
And now the question about the integration with GitHub or GitLab in order to have a source control for every stuff is running here is able. Where is the source of truth?
We'll actually touch on a little bit of a demo on that.
Oh, sorry.
You're teeing it up for us. Thank you.
Okay.
And the question that often comes that, especially as a Terraform junky, not in both the best and the worst way. Like, where is state held for this stuff? And this is one of the problems people.
Let's answer that question. Let's answer that question immediately. Excellent. So when the broker runs Terraform for you, and broker's generic, so CLI can be a broker. You could write a wrapper around any tool and make it a broker. That's the beauty of this work order mode pattern. It's actually storing the state data back into the cluster. So if I have 500 people running clusters, each cluster is going to have the state file associated with it. What Shane's showing you on the screen right here is the Terraform, the broker TF info for this cluster. It actually has the lock files for it, and the state information are stored back to the cluster that requested the broker run. And then this one's, we're here. If you scroll down, go ahead, you do it.
So one of the notes about not just the Terraform state is we manage state of the life cycle of both clusters, machines, and all of those automations. And that's what allows us, it's very similar to Terraform state, but it allows us to do operations with multiple tools in that pipeline. So we can jump from Terraform and maybe AWS CLI as an example, when Terraform doesn't have an abstraction in the provider to be able to do something. Then we can jump into some bash glue scripts to some Python scripts. And then maybe the security team has some Ansible scripts that they want injected to maintain a security posture for those services. So that's one of the benefits that we bring, is we can both manage the Terraform state and manage state holistically, that full life cycle management.
Instead of managers, you are state of states. Like you can actually maintain the state across multiple state requirements.
We can, but one of the things that we did is our state is mutable, and it's designed to be updated dynamically as an API. So unlike a state file where it's a locked thing and it's sort of an atomic unit, our state is actually decomposed into parameters, and then it's the system designed to take patches into the system. So I can update individual parameters, individual state information on any system without breaking it. And that's really important. And we'll go, I want to get into lock and unlock.
Okay.
But let's
Where do you want me to
scroll down. I want to make sure so one of the things that we've done in this is there's a debug mode in Terraform. So I'll go back into character a little bit. So Shane, you wanted to see the Terraform that's generated by Digital Rebar for us, right?
So I can see and touch and feel and taste what's actually going to happen.
So even though it's decomposed into a whole bunch of pieces that come together, at the end of the day, there's still a Terraform plan, and we turned on debugging so you can actually get the plan. Now, don't leave this on in production because it stores credentials and things like that, but you can actually go through and see Digital Rebar injected a whole bunch of information about the system. It comes back in and it's actually building our scripts and knowledge. It's building our security rules.
There's our security rules, which I was trying to hard code in my Terraform plan.
Exactly.
And these were dynamically generated.
Right. And so it's literally taking the information that we pass in when we create the cluster and then doing the work, and then even adding in the synchronization.
Synchronized thing?
The synchronization point is the part that actually creates and destroys machines when Terraform creates and destroys machines. So that's the hook that allows the systems to connect together.
Excellent.
But does that make sense? So now you see where the Terraform goes? Okay.
Now, I know you're probably going to get to this, and I don't want to.
Actually, I would love to take questions. We have more to show than we have time for, so questions would let us show the things that y'all are interested in.
One of the biggest things we have to have is the handoff between different systems. You kind of alluded to it, right? That we're going to have we use Terraform to get this far. Then there's a handoff to, somebody and their preferred tool is Ansible. And anybody that's used Terraform, they learned if you use the provisioners, there are ways to link in Ansible and other tools, which are they're brutal and they're brittle. It's risky to do. Even the people at HashiCorp say yeah, it's there, but be careful.
And yeah, this integration has been something that we really worked very hard to build and then field test. So what we're actually able to do in this is by creating the machines and then having the join up goes, we actually match a fingerprint. This is the same thing we do when we boot and reboot hardware. It's actually using the same join up mechanisms. And that means it's a very consistent approach across the board on how these things work. In this case, we're able to use the cloud IDs that the clouds provide and then match them when the machines come online. So
And so this way you're managing every single phase of the life cycle, you're managing against the core object. And this way you are the interconnect between all of these different phases of the life cycle.
And this is actually what we see our customers struggle with. So our customers have tools that they like to use, Terraform, Ansible, Chef, Puppet Salt, right? There's tons of tools. And what they already have working logic in those tools. We don't want to tell them rewrite anything. If they have an Ansible playbook that works, they should use it. It works. But what they really struggle with is the fact that they don't connect well between those operations. And sometimes it's a team problem as much as it is a tool problem. Now, Terraform doesn't have good integrations into the next tool over. It was designed to do one thing. Ansible doesn't have particularly good integrations to the next tool over. What we're actually addressing and what our customers really like is this start from one point, run a pipeline all the way through and end the pipeline. And one thing you might notice is when we run it, we're actually running a lot of steps that you're like, wow, all we need to do is run Terraform. Why am I watching a wall of actions scroll by? Those are actually standardized processes for the pipelines that you can then add to depending on what your needs are. So if we have somebody who says, oh, I need to run this special tool in the middle of my Linux provision or my Windows provision, whatever, there's a place you can add that into the standard pipeline. Standard pipeline keeps working. If we improve it or fix a bug, then those things actually become part of the standard. Their injected task stays where it was.
And there's other things that we can do in those standard hooks with RESTful callbacks to API services, validation, so you can pre-validate, post-validate that things are either ready to do something or have done something correctly. There's flexible injection of tasks. So you have this great workflow or this great pipeline, but I need to run this thing first. And then we can do classifications as well. So as we collect inventory information, we can make smart decisions based on this. That also lets us do intelligent forking in that whole pipeline. So the pipeline can be the same across both bare metal infrastructure as well as cloud resources, public cloud resources. And it'll make decisions based on, am I an instance in AWS? Am I a bare metal system? Oh, I'm a bare metal system. I need to do BIOS and firmware configuration and management, hardware, life cycle management. Now I can get to my operating system stuff. And so that gives us a really cool.
Fantastic.
It's very cool. Yeah.
Let's talk about that real quickly because we mentioned Raspberry Pi and one of the other delegates mentioned I can put RackN on the Raspberry Pi and deploy a ton of other Raspberry Pis. That's fantastic. But can I take a Raspberry Pi and deploy something bigger? Like, I don't know, the XRail cluster, UCS cluster?
Yes.
There is the thing that we're finding as we do more and more of this orchestration work, and we start putting tools in containers. You have to have a place to run the containers, and the Pis. What's for some of those use cases, the need to put containerized tools into the Digital Rebar system makes Pis not a particularly good choice.
Well, that's fine.
But
I can accept that.
But yes, and we actually the system can actually run commands on itself, and we take advantage of that quite a bit also to make bootstrapping easy.
So let's take it to a different level. If I was running your software, could I run it in something like a Vagrant VM running on a laptop? Or can I run it on a laptop?
Yeah.
And we do all the time. Yeah.
So the primary requirement is Linux. We started out with a vision to be able to run on Windows and Linux at the same time, but for practical reasons that didn't work well. So pretty much anything that's Linux, either from a VM, bare metal resource, we can run on it very easily. Our service is a single executable Golang binary. It's statically compiled. So it's pretty easy with Golang to cross-compile to different architectures and different hardware platforms that Linux supports. That's how we get the ARM support. We also run on some pretty exotic hardware and our large banking customers, and are starting to get into managing some of those really, I'd say, interesting legacy hardware platforms they still have kicking around.
The other thing we've been continuing to improve is how well we can deal with an air-gapped environment. So because of the infrastructure as code pieces, everything. Shane, can you go to the templates for me and show the locks? So there's a subtle thing that's going on here that this is perfect. When we build an infrastructure, the system itself brings in immutable automation. It's all versioned, it's all controlled. And if you look down this screen, it's subtle, but it actually has a whole bunch of locks, and the things that Shane built to test are unlocked. And so in this system, what we've actually been able to do is you can define everything about the system's behavior, profiles, data, variables, like all of it defined, including the containers, the tools, like it's designed to be a completely self-contained system. Because we have banks that say, if I have to build a new data center, you have 3 hours to bootstrap all the infrastructure. And I have to, you start from USB stick. So that's a core requirement for how we build the system. But what happens is that to do that, everything that's in the system definition is actually immutable inside each system. There's a very subtle point here, and we'll show this more in the third demo, but I want to reinforce it over and over again. That's what makes the system collaborative. When Bank N can define their unique infrastructure as code pieces and then slide it in like a module and then distribute it to all of their teams and know exactly what version of what automation their teams are running and know that nobody's come in and hacked in an extra, ooh, I fixed the bug, and then provide them with a development process where they can go update it, patch it, distribute it. That's what we do with automation. And the site definition and the ability to predefine everything in a site is absolutely key for that. It's part of the, and this is where, do you want to, let's jump into the Terraform. If you could go to the profile where we do the AWS code. I want to get us back on script. Because we're going to show and reinforce some of these other lessons, but I want to show you the Terraform pieces.
Which pieces you want?
The parameters, please. Not that one. The resource definition.
And just one other quick thing, because we talk about licensing and what you can maybe not need as much. In order to do a lot of what we typically do, we have to buy Terraform Cloud, Terraform Enterprise, we have to buy Ansible Tower, you have to pay for that, because we have to have some central owned managed system. It seems to me as though that then, because I used to cheat and I would run I would have these Ansible playbooks that I would push into my templates. I would deploy a VM and it would have all these local playbooks, and I would trigger them through remote vSphere jobs to get around me not paying for Ansible Tower.
You've just completely laid out the script for demo 2.
All right, then I'll save it for that one.
But yeah, we are a substitute for Terraform Enterprise and Ansible Tower, and actually let you pull those things together.
And so you get the win of not the OSS, like hope and pray state management, but you also cover the features.
Correct. And since we're designed self-managed first, we always work really well on premises, behind a firewall, with people managing it. We don't force somebody to take a patch to anything. You're always, because it's infrastructure automation. Nobody wants a forced patch or a change or a system down, right? They need to have that ownership. All right. And then we'll wrap this. This is really important because I want to show you how we actually do this composition. This is something that in character Shane would be very nervous about. You want to talk about this, please? Go ahead.
So this is where we define the templates that are being used by the resource broker specifically. So these are the defaults in here. If I wanted to make customizations, I assume I can set these.
And those are actually linting templates. So
these ones are linting, so I can guarantee the HCL syntax and
security. So if you want to add linting in, you can add linting into the requests. And by default, we're going to lint every Terraform plan that goes through the system. So just like a Terraform pipeline, we actually include that type of capability. And then these are actually the decomposition. So if you were to look at this Terraform initialization, sequence, group, and machines, it actually maps into initialization, security, and machines. But as a security provider or something like that, I could provide alternate templates in this and then compose them in. So if I wanted to design a different VPC, I don't have to rewrite a whole Terraform plan. I can just add in my own custom VPC or firewall rules or additional features that I wanted to include into that plan. I don't actually have to recarve the whole plan. So if you're used to Terragrunt or something that does composition of Terraform, this is a normal pattern for us. We do this all the time. We, of course, do have drift detection on this. So you can put all these clusters are in day 2 operations mode, and you can just run that Terraform, rerun the Terraform in plan mode, and then it'll actually raise errors if something has changed between the Terraform. It's a trivial.
Yeah, you basically just did the Steve Jobs. Oh, one more thing. We introduced we created a phone. Like, so we talk about pipeline, we talk about infrastructure as code, we talk about all these things, and that gets you to from day 0 to day 1/day 2. And like that concept of now drift becoming core to continuous operation.
Can you bring up
We
the
buried the
triggers
lead in a
for
way
second?
because this is actually the real problem that most people are not getting to yet.
It is the problem they're not getting to yet, and our goal in this is to show you how to step into the infrastructure, because this is the challenge. Right now, you can take Terraform and you can run Terraform. You need to understand that there is a way to scale Terraform across teams and across enterprises, but it requires you to look at your Terraform as individual code and build it up and have a place to run it. That then unlocks all of the orchestration pieces that we've enabled. So we actually built a trigger system. So what we've actually done with the orchestration, so let me lay this back. We have a way to create a work order that runs against a cluster that says, use my state file and tell me if there's drift. That's amazing. API call, really simple. We can push a button and make it happen. Our customers then want to say, wait a second, do that every night, do that every hour. So there's an orchestration system that lets me come in and say, every hour, do this work, run this blueprint against these systems, and it'll queue it. We're going to spend some time in that in the next demo. I can also do things like raise an alert and then let the alert system say, oh, somebody detected drift. I need to notify you in Slack that there's drift, and connect those things together. So the orchestration system actually has the ability to do all that plumbing now that we have an ad hoc request system. All right, everybody, thank you for seeing our first demo for Cloud Field Day. I hope this has been informative. I would encourage you, everything we're showing, you can do yourself and you can try and download. So if you go to RackN.com/trial, you can install Digital Rebar in the cloud. You can follow our interactive labs and they'll walk you through how to do exactly these same processes that we went through.